I'm Dr. Erica with Rosie Research, and I'm here to do this month's lab with you, which is Rosie Research and the Pirate's Treasure. So this month we're going to dive into buoyancy and how buoyancy works in engineering with some shipbuilding. That's going to be a lot of fun. You should check out our playlist for all of our add-on activities. We have a lot of fun add-on activities this month. And these are two different formats of the same lab, so choose the one that works best for your child. If they like more writing space, go for the bigger one. If they like less, the littler one. My kindergartner actually enjoys the littler one more. She said that it makes her feel like she's being more productive and that she can concentrate a little bit better. So I'm going to do the littler one. And of course, the first thing that we see when we open up our lab is the story of Rosie Research and the Pirate's Treasure. And it's kind of a fun way to bring your kids in and get them excited that they're going to save Rosie from walking the plank. And so we're looking at shipbuilding and how to float ships, which is buoyancy. So the first little bit looks at what is buoyancy. And the first sort of question here is called one floats and one sinks. And there's a little video in the playlist that you can click over to watch me doing this one floats, one sinks piece a little bit more in depth. But this asks you to say if it floats that the buoyant force is going to be the same as the weight, or a little bit, I mean, not necessarily larger, but it has the capacity to be larger than the weight, which is what will let us add in that treasure. And if it sinks, then the weight is bigger than our buoyant force, because the buoyant force up can't counteract our weight going down. And so it asks you to circle it in both situations. So in the first one, where we have a ship that's floating, we're going to have a bigger buoyant force because it's floating. So that buoyant force is big enough to float the ship, so it counteracts all of the weight that goes down. Now when I crumple it up in that other video, you see it sinks like a rock. And so that's because the weight now is bigger than the buoyant force for that particular thing. And so then you would circle the one where the weight is larger than the buoyant force. And if you're interested in why that is, again, check out that other video that we have in the playlist, because I'll go in depth and talk to you about why that is. And so then we have like sort of little fun little picture that says that when the buoyant force is less than the ship, it's going to sink to the bottom. So we don't want that. Now, if the buoyant force is greater than or equal to the ship, then we're going to float. And by greater than, I don't mean that we're going to just sort of jump out of the water. I mean, we can add stuff in to that ship and it's still going to float. So even if we increase the weight on the boat, the buoyant force is going to compensate for us. And so that brings us to figuring out how much treasure or booty our ship can transport. And we have another little situation of one floats and one sinks. And this time it's with a ping pong ball and a golf ball. And again, there's a separate video and a playlist that you can check out if you want to, that will go in depth about the ping pong ball and the golf ball and why one floats and one sinks. And in fact, we even have a ping pong ball with holes in it, and you can see what happens with that one. But our ping pong ball floats because it displaces enough water where the buoyant force going up can counteract our weight going down, and so it doesn't sink. So I have my weight going down. It asks me to draw the forces, and I have my buoyant force going up. Now you could write buoyant force, or you can use something that's shorthand. That's the force of buoyancy, so F with a little tiny b. And then my golf ball sinks. So here, my weight of my golf ball is really big. There's my weight. And my buoyant force is little. There's my buoyant force. And that's why it sinks, is because the weight is so big that the buoyant force can't catch up and it sinks to the bottom. And so then it talks about here, down below that, it's got those fun little pictures again, and it talks about adding in treasure. And it says if we add too much treasure, we kind of become that golf ball and we start to sink. And if we don't have too much treasure, then our buoyant force can still counteract the weight of the boat and the weight of the treasure, and we can float, which is good. So the next piece of the lab is going to the shipyard and building our ship. So it tells you all of the supplies you have that you can build your ship. foil, popsicle sticks, newspaper, tape, glue, and string. So no sort of preformed ships, nothing that's plasticky, just all what you can do with those supplies. And you have two challenges that you can do. One of them is to carry the most weight possible. So that in that situation, you're going to take your little boat that you engineer and you'll just add in as many pennies as you can, and you'll sort of see how much treasure does your boat carry. The other challenge is to see the stormy seas that your boat can survive. And so in that situation, if you're doing this in a bathtub or a sink, you can kind of go in and you can make it really stormy in there, and you can see how stormy can it be before your ship sinks, takes on water. So those are the challenges that you're going to do. And as you're building your ship on the next page, there's a little hull design space for you to draw what you want to do. So I give you some ideas of different types of hulls that ships have. And you can cut your foil if you want to make a ship that's sort of 2 hulls or 3 hulls wide and they're connected by popsicle sticks. Maybe that's the best way to do it. I don't know. But this gives you some ideas of hulls that you can make, and it gives you a space where you can draw a ship. So I'm going to think of a ship that I want to make, and then I'm going to draw it. So let's see. I'm going to make sort of an old school, maybe pirate ship. So I'm going to draw my ship. I want my hull to kind of look like this. It's going to come out of the water, maybe like this. And you can think about where you want to put popsicle sticks. Like maybe I'll put some popsicle sticks on the bottom for some extra buoyancy, maybe around the edges. And then once you have an idea, you can start to build it. And I'm going to build this ship. We're going to fast forward through it so you don't have to watch it slowly, but you can watch it kind of nice and quick. And you can see what we're going to build for our ship. Go with as my ship. I didn't use all my supplies, and that's okay. You don't have to use everything. And once you've made your ship, then you have a space in our lab where you can draw out your ship. And that just lets you have sort of an image of what you're going to do or what you had there, so you can look back at your lab book. And then you're going to float this either in your bathroom sink or the bathtub, and you're going to add in as many pennies as you can. So mom and dad, you might want to go to the bank and get a few rolls of pennies just to see how much can you do. And it can't be a submarine. So it needs to be actually floating on the water. Submersibles aren't allowed, and you want to just do it until it starts taking on water and sinking. And then you have a space and an area to draw for the first challenge where you get to redesign your boat. So you can think of a new idea that you're going to try to do, and you can draw it here. And once you've built it, you can draw your final ship that you built. And in each of them, you're going to figure out, count your weight of your treasure. And if you have a younger audience, you could just do the number of pennies, so maybe 20 pennies. For older kids, you can have them convert the pennies into an actual weight, and 1 penny is 2.5 grams. So you could actually have them find the weight in grams of that treasure they carried. And so you can compare trial 1 to trial 2. Did you make it better? Was it worse? What could you have done differently? And then you have the same space that you want for the Race the Atlantic. So you can either go at the stormiest seas possible, or have a fan in your bathroom and race across the bathtub if you want. And again, you have a space to draw a new ship and build that new ship, and then see how long it takes to get across the tub, or sort of what type of hurricane you can do. Now, you'll notice when you're doing this, maybe this ship carries the most weight of treasure, but it's the slowest one to cross the bathtub, or it capsizes the easiest. So you want to see if you can sort of ultimately design something that's fast and can carry a lot of weight and is really, really stable. So that's what we have for this month's lab. It's a little short in terms of the lab book, but really long in terms of the engineering. So the engineering part is going to be a lot of fun. You don't want to rush that. Just enjoy what you're doing. Take the time you need to build that ship, to test things, to see how good can you make it. If you want to do more than 2 trials, do more than 2 trials. And then we've got a lot of add-on activities that you can do to go more in depth. Ideas from the dancing raisins and learning about density or making a density column. For older kids, there's making your own treasure map. We learn about vectors and find treasure. So check out the add-on activities that are in that kit that you have, along with some sourcing places that you can get some cool pirate stuff, and also the parent-teacher guide or the scaling guide as well, in terms of other ideas that you can do to make it fun. I hope that you guys enjoy our Pirates Treasure Lab, and definitely join us on Patreon to become a patron of ours so that you can get all the labs as they come out every month. If you want to just get this lab, again, you can get it at rosieresearch.com/shop. We would love to hear your questions and comments down below. We'll definitely try to respond to everything. And follow us on social media if you want to see what we're coming up with next and all the fun activities. We're on Facebook and Instagram. And join us to become a STEM sleuth.